Imagine standing in a place so dry that some weather stations have recorded years without a single drop of rain. A place where the ground is so barren that entire valleys appear almost lifeless. Where rocks lie exposed under the sun for millions of years, barely disturbed by wind or water. Where the soil itself seems frozen in time, preserving ancient landscapes that have remained unchanged since before humans ever walked the earth. At first glance, the landscape feels alien. The horizon stretches endlessly across a vast plain of rust-colored sand and pale stone. Jagged mountain silhouettes rise in the distance like the ruins of some forgotten world. Heat shimmers above the ground in silent waves, distorting the air itself. There are no rivers, almost no plants, and for hundreds of kilometers, the land appears empty of life. If you were dropped here without context, you might assume you were standing on another planet. But this place is not on Mars. It is right here on Earth. In northern Chile, along the western edge of South America, lies the Atacama Desert, widely considered the driest non-polar desert on our planet. And according to many scientists, it is a desert that should not exist. Because when researchers began studying the region in detail, they discovered something deeply puzzling. By every normal rule of climate and geography, the Atacama should not be nearly as dry as it is. Most deserts on Earth follow a predictable pattern. Across the globe, large deserts typically form around 30 degrees north and south of the equator. These regions sit beneath powerful atmospheric systems known as subtropical high-pressure zones. Here, warm air that once rose near the equator eventually sinks back toward the surface. As the air sinks, it warms and dries. Clouds struggle to form. Rain becomes rare. This atmospheric engine is responsible for creating some of the most famous deserts on Earth. The Sahara in North Africa, the Arabian Desert, the deserts of Australia, even the deserts of the American Southwest. All of them sit within this global belt of dry descending air. But the Atacama occupies a far stranger location. Stretching nearly 1,000 kilometers along the Pacific coast of South America, the desert lies wedged between two powerful natural features. To the west lies the vast Pacific Ocean, the largest body of water on Earth. To the east rise the towering Andes Mountains, the longest continental mountain range on the planet. At first glance, this location seems almost ideal for rainfall. Moist air from the Pacific should move inland across the coast. Clouds should build along the mountains. Storm systems should deliver regular precipitation. And yet, almost none of this happens. Instead, the Atacama remains locked in extreme dryness. In some regions, the average annual rainfall measures less than 1 millimeter. That is less water than many places receive in a single hour of light rain. But what makes the Atacama even more extraordinary is that some areas appear to have gone far longer without rain than anyone once believed possible. Weather records from certain stations show decades without measurable precipitation. In some valleys, scientists suspect that rain may not have fallen for centuries. Entire landscapes exist that may not have experienced rainfall since before modern civilization began. This raises a remarkable question. How could such an extreme environment form on a planet covered mostly by oceans, a world where water constantly circulates through the atmosphere in an endless cycle? To understand this mystery, scientists began examining the invisible forces that shape Earth's climate. Because the story of the Atacama Desert begins not just with geography, but with the enormous planetary systems that move air and water across the globe. Every day, Earth's atmosphere is driven by a simple but powerful force. The sun near the equator, sunlight strikes the planet most directly, warming the surface and heating the air above it. This warm air becomes buoyant and begins to rise. As it rises, the air cools. Moisture within it condenses into clouds. Rain falls. This is why the equatorial regions of our planet host some of the wettest environments on Earth, including the vast Amazon rainforest that stretches across South America. But the rising air does not remain there. High above the surface, it begins to spread outward toward higher latitudes. Eventually, the air cools enough that it sinks back down toward the surface roughly 30 degrees north and south of the equator. When this air descends, something important happens. It compresses. And as it compresses, it warms. Warm air can hold more moisture, meaning clouds struggle to form. The result is clear skies and extremely dry conditions. This circulation pattern, known as the Hadley cell, creates many of the deserts found across our planet. And the Atacama does lie near this global desert belt. But scientists soon realized that this explanation alone could not account for the desert's extreme dryness. Because when researchers began studying the region more closely, they discovered that several powerful environmental forces had aligned here in a remarkably precise way. The first of these forces flows quietly along the western edge of South America. Just offshore, beneath the surface of the Pacific Ocean, runs a massive current of cold water known as the Humboldt Current. Originating near Antarctica, this current carries frigid ocean water thousands of kilometers northward along the Chilean coastline. Cold water has a profound effect on the atmosphere above it. When ocean water is cold, the air just above the surface also cools. Cooler air cannot hold as much moisture as warm air. As a result, large storm clouds struggle to develop. Instead of tall rain-producing clouds, the atmosphere forms thin layers of low fog. Along the Atacama coast, this fog is known locally as Comanchica. During the night and early morning hours, it drifts slowly inland, blanketing desert cliffs and rocky slopes in a soft gray mist. Tiny droplets of water collect on surfaces, sometimes providing the only source of moisture for certain plants and animals that survive here. But the fog rarely grows thick enough to produce rainfall. It is as if the desert sits beneath clouds that never quite release their water. Yet even this powerful ocean current does not fully explain the desert's incredible dryness. Because another enormous barrier rises just to the east. The Andes Mountains. Stretching more than 7,000 kilometers along the spine of South America, the Andes form one of the most dramatic geological features on Earth. Many of their peaks rise higher than 6,000 meters above sea level. These mountains act like a giant atmospheric wall. Moisture from the Amazon basin travels westward across the continent. Warm, humid air flows toward the Andes carrying enormous amounts of water vapor. But when this air reaches the mountains, it is forced upward. As it rises, it cools rapidly. And when air cools, the moisture inside it condenses into clouds and rain. Most of this rain falls on the eastern side of the Andes, feeding rivers that eventually flow into the Amazon rainforest. By the time the air crosses the mountain peaks and descends down the western slopes toward the Atacama, it has already lost most of its moisture. Meteorologists call this effect a rain shadow, and the Atacama lies directly within it. The result is a desert trapped between two powerful climate barriers. To the west, a cold ocean current suppresses rainfall. To the east, a massive mountain range blocks incoming moisture. Together, these forces create one of the driest environments anywhere on Earth. But as scientists continued studying the region, they began to uncover an even deeper mystery. Because geological evidence suggested that the Atacama's dryness might not be a recent phenomenon at all. Instead, it may have persisted for millions of years. And if that is true, then the Atacama Desert is not simply one of Earth's driest places. It may be one of the oldest continuously dry landscapes on the entire planet. Which raises an even more fascinating question. If this desert has remained so dry for so long, how could anything possibly survive here? And as scientists began exploring the silent valleys and ancient soils of the Atacama, they would soon discover that the desert was far from lifeless. Because hidden within this seemingly impossible environment, life had found a way to endure. And what researchers uncovered next would not only reshape our understanding of extreme ecosystems on Earth, it would also transform the way scientists search for life beyond our planet. And what researchers uncovered next would not only reshape our understanding of extreme ecosystems on Earth, it would also transform the way scientists search for life beyond our planet. For decades, scientists believed the central regions of the Atacama Desert were simply too hostile for life. The landscape seemed to confirm this assumption. Vast stretches of the desert floor appeared completely barren. There were no shrubs, no grasses, and no visible signs of animals moving across the terrain. Even insects were rare. In many locations, the soil looked almost sterile. When researchers first began collecting samples from these areas in the mid-20th century, the results were surprising. In laboratory tests, some soil samples showed extremely low levels of organic material. Microbial activity, normally present even in harsh environments, was almost undetectable. At the time, this puzzled scientists. Even the most extreme places on Earth usually host some form of life. The Sahara Desert contains microbes adapted to intense heat and dryness. Antarctica's icy valleys contain bacteria that survive in sub-zero temperatures. Even deep underground, organisms thrive in environments without sunlight. Yet parts of the Atacama seemed almost empty. But something about this landscape intrigued researchers. Because the more closely they examined the desert's chemistry and physical conditions, the more it began to resemble a place far beyond Earth. Mars. The Atacama Desert shares remarkable similarities with the Martian surface. Both environments are extremely dry. Both contain soils rich in oxidizing chemicals that break down organic material. Both receive intense ultraviolet radiation from the sun. And both lack the stable liquid water that life typically requires. For this reason, planetary scientists soon began using the Atacama as a natural laboratory. Robotic instruments designed for Mars missions were brought into the desert to test whether they could detect microscopic life under conditions similar to those on another planet. Researchers deployed experimental rovers, spectrometers, and drilling equipment across the desert floor. These technologies were designed to identify chemical traces of biological activity, the same types of signals scientists hope to detect on Mars. But during these experiments, something unexpected began to emerge. The deeper researchers looked, the more they began to realize that life had not disappeared from the Atacama after all. It had simply adapted in ways that were almost invisible. Hidden deep within the desert's rocks and soil were tiny organisms that had evolved extraordinary survival strategies. Some microbes live inside microscopic cracks within rocks, using the stone itself as protection from harsh radiation. These organisms are known as endolithic microbes, meaning they live within rock structures. Inside these tiny cavities, the rock filters sunlight and traps small amounts of moisture. This creates a fragile microenvironment where life can persist even when the surrounding desert appears completely dry. Other microorganisms have evolved an even more unusual strategy. Instead of relying on rainfall, they extract water directly from the air. Even in the Atacama, the atmosphere contains trace amounts of moisture. Certain microbes absorb this humidity through specialized cellular mechanisms, allowing them to survive without liquid water. Some species remain dormant for years or even decades, waiting for extremely rare environmental changes. Because although rainfall in the Atacama is incredibly rare, it is not entirely impossible. Occasionally, the climate of the Pacific Ocean undergoes dramatic shifts. One of the most powerful of these events is known as El Niño. During El Niño years, warm water spreads eastward across the Pacific toward the coast of South America. This disrupts the cold Humboldt Current that normally suppresses rainfall in the Atacama region. As the ocean warms, the atmosphere above it also changes. Moisture increases. Cloud systems grow stronger. And for brief periods, rain may finally fall on the desert. When this happens, something extraordinary occurs. Seeds that have remained buried beneath the sand for years suddenly awaken. Within days, the barren desert floor begins to transform. Tiny green shoots emerge from the soil. Bud after bud begins to open. And soon, vast sections of the desert explode into color. This rare natural event is known as the flowering desert, or desierto florido. Millions of dormant seeds respond almost simultaneously to the sudden presence of water. Fields of flowers stretch across valleys and hillsides that appeared lifeless only weeks earlier. Purple blossoms of Nolana plants spread across sandy plains. Yellow patches of cistanth flowers glow beneath the sun. Pink and white petals ripple across the landscape like waves of color. For a short time, one of the driest places on Earth becomes a vibrant ecosystem. Insects return. Birds arrive to feed on seeds and nectar. Small animals emerge from underground shelters. Life surges across the desert in a sudden burst of biological activity. But this transformation is temporary. As quickly as it appears, it fades. Within a few weeks, the rainwater evaporates. The soil dries once more. The flowers wither, leaving behind seeds that fall back into the sand. And the Atacama returns to silence. Yet the discoveries made here have had profound consequences for science. Because the deeper researchers studied these resilient microbes and rare ecological events, the more they began to reconsider the limits of life itself. For much of scientific history, life was thought to require relatively stable conditions, consistent water, moderate temperatures, and protective atmospheres. But the organisms of the Atacama have shown that life can persist in environments far more extreme than previously imagined. If microscopic organisms can survive inside rocks in the driest desert on Earth, then perhaps life could survive in similar refuges elsewhere in the universe. This possibility has become particularly important in the search for life on Mars. Today, scientists believe that if microbial life ever existed on the Red Planet, it may still survive underground, protected from radiation and extreme temperatures beneath the Martian surface. And the survival strategies observed in the Atacama may offer important clues for how such organisms might persist. In other words, this silent desert on Earth may hold the key to understanding life on another world. But as researchers continued studying the Atacama, they began to realize that the desert was not only revealing secrets about biology. It was also preserving an extraordinary record of Earth's own geological history. Because in a place where rain almost never falls, landscapes can remain unchanged for millions of years. Ancient surfaces remain exposed. Mineral deposits accumulate undisturbed. And beneath the desert floor lies a hidden archive of planetary history waiting to be read. And when scientists began examining this geological record, they uncovered something even more surprising about the desert that should not exist on this planet. And when scientists began examining this geological record, they uncovered something even more surprising about the desert that should not exist on this planet. To the casual observer, the Atacama Desert appears almost timeless. Its landscapes seem frozen in place, as if the region has always existed in this silent and barren state. But the deeper scientists investigated the desert's geology, the more they realized that the Atacama is not merely a dry landscape. It is a window into Earth's ancient past. In wetter environments, the land is constantly reshaped. Rainwater erodes rock. Rivers carve valleys. Vegetation breaks down soil and transforms the terrain over time. Landscapes evolve continuously, and traces of the distant past are gradually erased. But the Atacama is different. Here, rainfall is so rare that erosion occurs at an incredibly slow pace. Without flowing water to reshape the land, geological surfaces can remain exposed for millions of years. Some areas of the desert preserve ancient landscapes that have barely changed since before the rise of human civilization. In fact, certain rock surfaces show signs of exposure dating back as far as 10 to 15 million years. For geologists, this makes the Atacama one of the most valuable natural archives on Earth. Within its soils and mineral deposits lies a detailed record of long-term climate change. Layer after layer of salts, nitrates, and other minerals have accumulated across the desert over vast stretches of time. Because rainfall is almost non-existent, these deposits are not washed away. Instead, they remain preserved in the ground, allowing scientists to study how Earth's climate has shifted over millions of years. These discoveries have helped researchers understand how atmospheric circulation, ocean currents, and mountain formation shaped the climate of South America. But the Atacama's mineral wealth would eventually attract attention for another reason. In the 19th century, scientists and industrialists discovered enormous deposits of sodium nitrate buried within the desert. At the time, nitrates were one of the most valuable resources in the world. They were essential for producing fertilizers that could dramatically increase agricultural productivity. They were also used to manufacture explosives and gunpowder. Suddenly, the silent desert became the center of a global economic boom. Mining towns sprang up across the barren landscape. Railways were constructed across hundreds of kilometers of desert to transport the mineral-rich soil to coastal ports. Thousands of workers moved into the region, building communities in one of the most inhospitable environments on Earth. For decades, Chile's nitrate mines supplied much of the world's demand. But this prosperity did not last forever. In the early 20th century, scientists developed new industrial processes for producing synthetic fertilizers. These innovations drastically reduced the need for natural nitrate deposits. Almost overnight, the desert's mining industry collapsed. Many of the once thriving towns were abandoned. Today, rusting machinery, empty buildings, and silent railways remain scattered across the desert floor, ghost towns slowly fading beneath the relentless sun. Yet despite this brief period of human activity, the Atacama remains one of the most untouched landscapes on Earth. And ironically, the same dryness that once made life here so difficult has also created one of the most perfect environments on the planet for observing the universe. High above the desert floor, the air is extraordinarily clear. Clouds are rare. Humidity is almost non-existent, and the atmosphere remains remarkably stable during the night. These conditions make the Atacama one of the best locations on Earth for astronomical observation. Today, some of the most advanced telescopes ever built stand atop the desert's remote mountain plateaus. Facilities such as the Atacama Large Millimeter Array peer deep into space, studying the birth of distant stars and the formation of galaxies billions of light-years away. From this silent desert, scientists are able to observe some of the oldest light in the universe. In a strange way, the Atacama allows humanity to look both backward and outward. Beneath our feet, the desert preserves the geological story of Earth's distant past. Above our heads, its clear skies open a window to the earliest moments of the cosmos. But perhaps the most remarkable lesson of the Atacama lies in what it reveals about life itself. For generations, scientists believed that life required relatively stable environments to survive. But the organisms hidden within this desert have shown that life is far more resilient than we once imagined. Even in a place where rain may not fall for centuries, even beneath relentless sunlight and crushing dryness, life endures. Tiny microbes cling to rocks, absorb moisture from the air, and remain dormant through decades of silence. They wait patiently for the rare moments when conditions briefly change. In doing so, they remind us of something profound. Our planet is far more adaptable than we often realize. The boundaries of life are not defined by comfort or abundance. They are defined by persistence. And if life can survive in the driest desert on Earth, then the universe may hold far more living worlds than we have ever imagined. Because sometimes, the places that seem the most impossible are the ones that reveal the greatest secrets of all.